be discussing the controversy behind nuclear energy, being presented by Connor Hernacki, Jacob Segal, and Ford Bockel. So, what is nuclear energy? Put it simply, this form of energy is released from the nucleus of an atom, as described by the International Atomic Energy Agency. Now, compared to other forms of renewable sources, nuclear energy is one of the safest forms of energy. The Office of Nuclear Energy has found that nuclear power produces massive amounts of carbon-free electricity, powering communities in 28 U.S. states. Because of this, it serves as a great way to combat climate change. With all that being said, there are still some problems with nuclear energy that need to be addressed. For one, radioactive waste is the byproduct of nuclear fission and is stored deep underground. But what will happen once these depositories are full is up for debate. Producing nuclear energy is also a very expensive process and is especially made difficult by the number of regulations on nuclear plants. And this leads to our main problem. Nuclear power is not being implemented enough when it should be. In other words, the public is too skeptical of power plants because of past meltdowns and recent misconceptions. And so more regulations are being implemented to ensure that the plants are safe and don't cause panic within the public. However, these regulations make the process very particular and expensive, discouraging companies from investing in them. And so there needs to be action towards swaying the public to be more in favor of nuclear power. And this diagram demonstrates the importance of public trust. A lack of trust or harmful effects from nuclear energy will cause the public to view nuclear power as too risky. However, with enough faith from individuals, it will positively affect the acceptance of nuclear plants, opening up opportunities towards the use of nuclear plants worldwide.
Solution 1. Introduce nuclear power concepts in educational curriculums, specifically that of middle school and high school. The failure of the American education system regarding nuclear power. Average people are uninformed about nuclear power because they never covered the topic in school. Nicholas Brown of the Nuclear Engineering Department of the University of Tennessee states that common television films like The Simpsons mislead people about the true nature of nuclear power. However, including nuclear power in educational curriculums would make average people pro-nuclear. Richard Rhodes, who is a scholar of Harvard, MIT, and Stanford, explains that radioactive waste and its disposal causes environmental problems in the public eye, but it is greatly exaggerated. Over time, the increase in public awareness will make it so that politicians are encouraged to implement nuclear power plants. The Office of Nuclear Energy, which is a government institution focused on the advancement of nuclear technology, has arranged conferences with students of the high school level to talk about nuclear energy. All students show a 100% understanding of nuclear energy's safe and sustainable nature. Pros versus cons. Pro 1. It will be extremely effective in implementing nuclear power plants. For example, according to the U.S. Department of Energy, the French people's support of nuclear energy led to France generating 68% of their power from nuclear energy. Pro 2, it increases public understanding with the secondary gain of improving America's education. However, con, this process simply takes too long. It will take a year minimum to change school curriculums, years for public conceptions to shift to pro-nuclear, and on top of all that, it will take decades to construct nuclear power plants.
Now this moves us on to our second solution, which is implementing newer technology. Now, first, let's take a step back and just look at what's currently wrong with the technology. Now, current nuclear plants, first of all, are dangerous. As the National Cancer Institute has said on many occasions, that meltdowns and accidents in nuclear plants can cause deadly ionizing radiation to be released, which causes cancer. As well as that, Joanne Liu from the International Atomic Energy Agency talks about how poorly optimized current nuclear plants are, as they're only really applicable for big major cities and just can't be used for the majority of populaces in America. And then there's the waste, where the Nuclear Energy Institute says that there are 80 tons of nuclear radioactive waste that releases that same ionizing radiation that causes cancer, produced every single year. And what's the solution to this? Well, small module reactors, also known as SMRs. Now let's dissect that name. Small module reactor. Obviously they're small. They use much less fuel, and they produce much less power, which makes them more easily usable in smaller areas. Then there's modular, where parts of the reactor can actually be made in a factory and then can be shipped to the site itself instead of just purely being built there. Now this information all comes from Joanne Liu from the International Atomic Energy Agency, which she then highlights some more benefits of this, being that they are much more applicable in the nature of them being small, where they can be used for smaller cities and towns, not just huge metropolises. In addition, they need 60% of the required fuel, which means that they need much less upkeep, but also that they produce much less waste, making them much safer. And in addition to this, there is much less danger, also proportional to them being much smaller. As Joanne Liu again says, that in comparison to existing reactors, proposed SMR designs are generally simpler, and that the safety concept for SMRs often relies more on passive systems and inherent safety characteristics of the reactor, such as low power and low operating pressure. But then after all, which is better, education or innovation? Well, when coming to our conclusion, we mostly relied on just the implementation of it. And unfortunately, education has some major drawbacks. As Olaf Jorgensen, someone who is a major administrator at a country day school and who has produced many education materials, personally attests, as he also works for the National Association of Independent Schools, just how hard it is to implement new materials into a curriculum, especially for something as basic as this and for implementing it nationwide, which leads us to SMRs being better, as they're already being implemented widely, such as Russia's Akademik, which is the world's first ever floating power plant, which gets its power from 2 SMRs. In addition to that, many countries, such as Argentina, Canada, China, Russia, the US, and South Korea, are already using SMRs. But they're not only using it for basic energy production. Over 80 designs focusing on a multitude of things, again quoting from Joanne Liu, said that they're being used for different applications, such as electricity, hybrid energy systems, heating, water desalination, and steam for industrial application, which all leads to SMRs being the future of a sustainable power source for the world. Thank you.
Nice. Okay, guys, I have a few questions for you, and then we can wrap things up. So first, Jacob, reflecting on your colleagues' work, both these other guys, which one had the greatest impact on your understanding of the problem? Whose paper would you say did that for you?
My colleague, Mr. Vogel, or Ford Vogel, he talked about the futuristic lens of nuclear power compared to my environmental lens. And so what I was talking about and what I identified as the main problem was people weren't educated enough, and you can't implement the technology if people won't vote for it, for politicians that will implement it. However, Ford solved this problem differently with small modular reactors. I personally thought this was a great idea because it's much better for scalability in that they are modular, and it's much better for it's much more practical because it's better for smaller towns and even individual homes.
what's an example of a compelling argument from one of these guys' reports that didn't make it into the presentation, neither part of the solutions or the problem? And maybe how come? Like, what was it about that argument that it just didn't fit with what you decided in the end?
So for Ford's arguments, we were discussing about radioactive waste and finding a better way to store it, but in order to do that, we would need to have nuclear energy be worldwide, which is what we're currently going after. So in order to counter it, combat it, we're gonna need to solve the issue of it not being worldwide.
Okay, terrific. And then finally, Ford, you guys were the smallest group at only 3 participants. So there's a lot of room in this one. If you had a 4th team member, like most of the other teams, what area do you think you would have had that person research that would have helped to round out what you guys were able to do?
Well, I'd say currently with our small group, our biggest weakness is in the economic lens, as we don't have much material on, how expensive it is to set up reactors, or even how that new, very sustainable source of power would impact the entire economy, especially the power sector as a whole. And so I think someone with the economic lens would be a great addition to our group if we had another member.
Great. Thanks, guys. You're all done.
Great.